The water gets into these farm plots by a network of ditches. So if you raise the water up in the canal, it'll seep in and it'll feed the farmland. And if you want to drain it, pump the pump station, it'll pull the water out.
Now we're going to start talking about the concepts that are important in order to understand the triple bottom line scenario sites. As you already know, sustainability means that humanity can meet the needs of the present without compromising future generations. And sustainability research focuses on the resilience of natural resources and ecosystem services. But how do we know if we're on the right path? That's where boundaries come in. Scientists have identified planetary boundaries in which humanity can operate safely. These boundaries include global environmental processes like climate change, freshwater use, and biogeochemical flows of nutrients like phosphorus and nitrogen. But sustainability challenges are not simple puzzles. They are weak problems. And weak problems are difficult to solve because our world is integrated, dynamic, adaptive, and heavily influenced by human activities. That makes it tough to find a one-size-fits-all solution. Another challenge is scale. Planetary boundaries operate at a global level, but solutions often need to happen locally or regionally. We must downscale, adapting big ideas to specific places, and test new innovations in real-world settings. How do we tackle these weak multi-scale problems? Through convergence research, using a design thinking strategy that combines multiple forms of expertise, integrates different methods and sources of data, build bridges across disciplines. But here's the thing, overcoming disciplinary boundaries isn't easy. It requires building a shared language, concept, methods, and data across diverse fields. And for that, research organization needs special tools to accelerate and support this integration. One of those tools is a boundary object. Boundary objects are focal points that enhance communication between different groups. They can be tangible, like a diagram or a map, or intangible, like a classification system. In research, boundary objects allow each discipline to interpret the same information differently, bring their unique perspective and questions, yet still collaborate towards a shared understanding. Boundary objects aren't just concepts. They can be physical places too. A landscape or ecosystem can act as a boundary object, where researchers pursue individual projects while still assessing the collective impact of their work. The boundary object isn't about measuring sustainability directly. It's an artifact, a tool, that facilitates interdisciplinary collaboration and discovery. And that brings us to the triple bottom line concept. Originally a business concept to include social, environmental, and economic factors of sustainability, it's now expanded into broader research frameworks. It's about considering three pillars. Planet, where researchers explore how human activities impact natural systems. Prosperity, where researchers measure the economic impacts of environmental challenges and potential solutions. And lastly, people, in which researchers investigate how society influences and is influenced by sustainability challenges and innovations. To connect all three pillars, researchers use triple bottom line scenario sites. And TBL sites are physical ecosystem boundary objects that supports holistic interdisciplinary research and foster collaboration between universities, research centers, and communities. But developing a TBL site isn't random. It follows key guidelines, like geographic location with a definable ecosystem, research resources to build upon, proximity to researchers to ensure access and participation, and a strong stakeholder network to integrate local perspectives. For example, the STEP Center is built around exactly these principles. It's a multidisciplinary research organization. It has a clear boundary: phosphorus sustainability issues. The center is in proximity to different research facilities and universities. It has access to research resources like long-term data sets, experimental sites, and technical expertise, allowing researchers to set up real-world experiments and collect meaningful data. And crucially, STEPS maintains a strong stakeholder network, partnering with governments, industries, local communities, and technology users to ensure that its research is relevant and applicable. And those were the main concepts around a triple bottom line scenario site. In the coming videos, we're going to show you different examples, like the urban, agricultural, and aquatic TBL sites. And finally, we're going to see a cross-site comparisons to get new findings. Thank you for watching.